Okay, this time on the laboratory, we are going to be doing the Day of the Dead. Characters that are magnetic are in the box. Just like in one of the previous videos, I'm going to leave it in the box so I don't drop or break or lose the characters. But if I turn it on, this plate is supposed to spin. You can see it spins really slowly, and I don't know if the camera's going to pick it up, but it's making a clicking sound. So, something's dying inside here. So we are going to see what it takes to open this up and fix it. So, first things first, remove the power. And the bottom, the foam has been removed. And the bottom's been removed. It looks like it's held on with Velcro. Interesting. There we go. Alright, on this, you can see it right there. There's the circuit board. And to disconnect the motor is just one little connector right there. And that separates the motor right here. And this center section, so we can now take this, move it out of the way. But it does allow us to plug this back in outside and use the power, which is kind of nice. And there's 3 screws in the dead center that hold it in place. I'm just looking underneath to see what might be going on. So we need a Phillips screwdriver. One that's not covered in hot glue from the last one. And there's 3 screws on the bottom. Okay, 2 screws in the bottom, 1 screw's missing. If I have one, I'll replace it. I should have a small hobby screw over there. That allows us to remove the center, which you can now see here's the motor, which we got lots of dry grease around it. And here's the little gearbox with another one of those famous gears that is notorious for not being able to be replaced. And a lot of really dry grease. It's like concrete. That could pose a problem if there's lack of lubrication. So let's open the gearbox. Just try not to throw the screws inside. Now, of course, if you have this, it probably doesn't have the Velcro to hold the bottom in. So, and now I'm going to take a peek at the gears. A lot of slack. Might be a bad motor or a bad pulley. Everything on this is stretched. I don't know if you can see how much wiggle there is. You can also see where it's been eating up the top that holds it in place. There's a lot of wear. I'm going to pull the top off. There's the satellite gears, and the lubrication is still slimy, but it's still not good enough. So let's plug it in and listen to it and look at it. So I'm going to use the factory power and not make an adapter out of random wires or components for my power supply, since we can just do this and that, and then we can just turn it on. And the motor's not even an attempt to turn. I'll even remove this gear to remove all the stress. This motor is not attempting to do anything. I believe it's going to be a bad motor. So let's pull out the entirety here. Put this back in so we don't lose it, misplace it. And then I'm going to stick this back on so none of the gears fall out when I turn this thing upside down. Let's unplug it again. And pull this out. The motor sounds okay. So let's give it some power and see if maybe it was the circuit board's not sending enough juice. Alrighty. It also could be that the base popped off the circuit board, that the solder joint has failed, and that is part of the problem, because that is supposed to be attached to the circuit board. And yeah, no, this motor is not working. So I think it's a combination of things. I think the motor's bad. Let's try something. Oh yeah, this thing's got a bad motor and a bad solder joint on the circuit board. I am giving it tons of power and, well, 4 volts, not tons. The motor has resistance, tries to start spinning, and then it stops. So, has a bad motor, and we're going to have to pop the circuit board off to resolder that pin back in. Unplug it. Circuit board's just held on with some hot glue. That's all. Doesn't look like there's a lot on there. There's enough that I'm probably going to have to heat it up. I'm going to lower the temperature of my heat gun. The nose fell off. That's what you heard bounce. So if you have an adjustable heat gun, I have mine set for 120 degrees Celsius, which is a low setting. The lowest it can go is 100. Reason being is there's only one big component on this little circuit board, which is a capacitor. And I don't want to get it super hot to where it might pop. It would be easily replaced, but I'm trying not to add any more work. Here's your circuit board. There's the front. And on the back is just two wires, which is the power wires, which then go through a couple of contacts to the motor and a capacitor, which is a smoothing capacitor. There's nothing else soldered to this board. It's basically just a power transfer. Transfers the power from the AC DC converter adapter, and then takes it, smooths it for the motor, and then sends it through. The smoothing is so the motor's electric field doesn't interfere with the LEDs and cause them to flicker. So, but with the circuit board out, I can flip it over and use some helping hands to, one, stabilize this so it doesn't keep trying to rotate on me, and two, hopefully I can get one of these arms in here to hold the circuit board so I can fix the solder. Like that. There we go. And I'm just gonna prop that there as an extra support. So the solder balls on the back aren't the prettiest. They're pretty blobby. Probably used a non-leaded solder, or it was resoldered and it was the wrong temperature. Any number of things. So turn off the air and turn on the soldering iron. And then for the motor, we're going to have to replace this motor with something that actually spins. So while my soldering iron is getting up the temperature, let's get this motor out. Try not to lose the little screws. I say it every single time I do one of these to let you all know that they are really hard to find if you lose them. Apparently this pulley does not fit through the hole, which is amazing because that's the first time ever on a Lemax. Set that with the screws up, get the pulley out of my way. Oh yeah, this motor's got corrosion on the front. It doesn't feel chunky. A lot of motors, when you spin them, they'll feel chunky. So, all right, soldering iron's up to temperature. So let's fix this. So there's two blobs. I don't know if you can see them very well. There's one on the left, one on the right. The one on the right is the pin that's still stuck in, which is good. The one on the left is a pin that needs to go in. But I want to remove that blob of solder before I do anything. You can use a solder wick, or I prefer a solder sucker. I've never had much success with the solder wick, although I have lots of it. And that sucks the blob of solder off and spits it out over there. I'm trying to get it all back in. There we go. Alright, so the pins are now sticking through, and I'm going to remove that other blob, and I'm going to resolder this with a nicer solder bead with some nice lead solder. So we have better connection. And I'm going to put a little more flux on here, just because they're old pads. There we go. Much better solder joint. Beautiful, nice and shiny, and has a nice curve to it. So the connection right there is going to be much better for the new motor. And I have a motor sitting right here. I think I use this motor as a to show you how to, see that the motor's spinning by putting a little mark on it. But let's test this motor, because this is in my good motors. I think I just use it, like I said, as a test motor. Yep. See the black dot's gone, and the black dot's back, so it's spinning. Drop off the pulley. Now, this is a high-speed motor. It's the same basic motor, but it has a higher RPM. This one's rated for 14,000. The torque motors are rated for around 10,000. So, before I put this in, take a small piece of paper towel, and I'm going to clean off the corrosion on the bottom of this plate where this mates. It's not really going to affect the motor, it's just going to affect how flat the motor sits onto the plastic so it's not wobbly. If you've never done one before, the motor has a whole bunch of little holes in it. As you can see, they go around the outside with an oddball that's off-center. The outer holes that are all equidistant are any position. You can clock the alignment. As long as you get the two screws to line up in the two holes and the motor is center inside the center of its ring. Sorry, there is grease on my fingers because there is some grease still left. That's why I dropped it. And there's the hole. So this one should be pretty close right there. And right there. There we go. Do not over torque it, you'll break the screw or you'll break the motor casting, which if you break that, you can just rotate it one set of screw holes and you're good to go. So, this is not cracked, so I'm checking. She's good. Just slide it back on and then adjust the height so when you look at it from the side, the two pulleys are the same height, so that way the belt is in alignment and not offset. Not only is this a little slick from some of the oil and grease, still healing from that last video where I sliced the top of my thumb, and my thumb's a little tender at the moment. So that's all good. Now, let's give this thing some power again and see if all these gears turn just like they're supposed to. Make sure there's no load issue. Oops. Look at that. They're all spinning. Keep those apart from each other this time. You should be able to see that outer one spin. Pulley spinning beautifully. So we're good. Now we just need to add some lubrication. Alrighty. I know I had that other. Just checking this 10-tooth gear real quick while I'm here again. It looks like it was cracked, but it's not. I think it's just dry lubrication stuck inside the teeth. Okay. All right. Well, we're going to hot glue this back in. So I'm going to get the hot glue gun warming up. And while that's warming up, let's start the reassembly of this. There we go. It only goes in one way. You just got to line up the triangle pattern to make it fit. These screws are not magnetic, or not very magnetic. And one more screw there. So I do want to get the center back together enough that we can load test it. Could have sworn there was 3 screws when I took this apart. Where'd that screw go? Still not warm enough yet. Well, like I said, I got a hobby screw sitting off the camera edge here. So we'll replace it. Same thread, different head. There we go. We are going to have to do some more soldering because we have to solder this connector onto these wires. So don't throw it away yet. Got it right there. Get this crappy motor off of the side of the bench where I have all my good stuff. But before I solder it, because it's very important this spins in the right direction, I'm going to just twist the wires together and test them using the factory power. Technically, I guess this one doesn't matter because they just spin in circles, but some of them do matter, and what you do is just as a temporary connection, just twist the wires together, which are way easier when you don't have a sore thumb, I'm going to tell you that. So I'm going to twist the red to the red and the black to the gray, since the new motor is gray and... I'm sorry, the old motor was gray and red, and the new motor is black and red, which is usually the standard. So And then you just make sure they don't touch each other when you plug it in. But I still want to get this circuit board glued in. Haha, there we go. So. Not quite fully up to temperature. Alright, so plug it in. Give me my power. Plug it in. I guess it's not going to load test without the center section, so let's unplug it and put the center section together. Ah, there's that missing screw. Apparently got stuck to the magnet. So I'll swap it out. And I'll use that screw for the one that's missing on the bottom. Like I said, the difference is the head. This has the same head as the bottom screws, which is a button head. This has a tapered head. So it fits flush, which it technically doesn't matter in here because there's nothing that is going to fit flush against. Go. So now it's fully loaded with all of its friction. Plug it in. Do you lose power? Well, that's no good. Just check on the solder joint to see if something broke free. These two wires are, glued and brittle. Or if when I broke the glue, if I broke the gray wire. Let's take a look. That has happened before. When I've separated glue, it's caught a wire and torn it. Oh, let me make sure. Because I should have power. Just got to remove all this hot glue that I just glued on. this is typical. You know, you think you got it all done, good to go, and then something stupid happens and you got to figure out what happened. I wonder if the wire that's connected to the plug broke or my power supply died. Oh, power supply's good. But we just want to troubleshoot our way through, so I'm going to turn this on to see if it makes power go through the plug here. .5 volts, so that's good. Let's trace the wire and make sure I didn't break it like I said. That goes to the switch, which then the switch goes to this wire. Yeah, I think I broke it inside the glue. Yeah. So going from the immediate connection to the first solder joint, there is no voltage. So looks like I broke the wire inside this glue puddle when I was prying it up, most likely. So I'm going to soften it, pull it out, fix it because there's a splice in there, and then I'm going to test it again. And then we'll re-glue it, of course. There's the broken wire. So, yeah, that's why she's not working. That's the hot wire coming in from the power supply. So you just got to be careful. It happens, unfortunately. These wires are so thin and fragile that sometimes when you're pulling stuff apart, especially when it's hot glued, the wires break, and it came off at the splice. This wire is gray, this wire is green, they were spliced in the middle. They used the hot glue to hold it together, and probably when I was pulling the circuit board off to fix it, it probably pulled the wires apart. So let's fix it again. Let's fix it a little bit better than they did. We don't want this to happen again if it ever has to be opened up to replace the belt or a gear. So first thing I'm going to do is we're going to strip some clean wire. Yeah. On both the gray and the green. Green wire is just a little shorter. Now I'm going to do the green wire much farther down. The reason being is the green wire is stretched. Probably again from pulling it off the glue. So I'm going to go to where the wire doesn't have any stress on it. And then strip it like so. Get the soldering iron going. And we're going to solder these together, and then we're going to retest it. And I should take care of it. Unfortunately, it's not the first time I've had it where the wires have broke, because what they do is Lemax either twist the wires and puts a little dab of solder on them, or they twist them and then they hot glue the wires together. And unfortunately, sometimes in those big globs of hot glue, you do not see it. So I like to solder them with good solder, so that way if it's in the hot glue, which it will be again because I have to hot glue this so it's out of the way of the moving components, you don't have as much of a risk of having them pull apart or break. They still can break because they're such thin wires, but and plug it in. Voila! Lights. So, not too bad, very simple repair. Easiest way to tell if you think you broke a wire is if you trace the power wires coming in, they always, and I don't know why, they always have a splice. I've come across 0 houses that I can recall that they've never spliced those wires, and I'm not sure why they do that. So, I'm waiting for my hot glue gun to increase in temperature again. Let's plug in this motor and use its own power to test it again. This time it should spin. Dink. Oh, apparently not. Oh, you gotta love trial and error. So, let's see. Sounds like it's got a broken gear. Yeah, when there's a load on it, remember I was going to load test it. I don't know if you hear that clicking, I'll be quiet. Sounds like one of the gears inside actually might be broken. Looks okay. Looks okay. That one's okay. this one's pressed on, so there's really no way to look at it without prying it off. No, this one looks okay too. I still don't like the hard stuff in it. Maybe I'll let's clean it real quick, see if that's the biggest issue. Okay, gotta go find that. Because it's pressed on, I'm putting the screwdriver underneath to hold the pulley up so I can push this thing back on. That way it goes back to where it's supposed to be. There we go. It's almost all the way down. Like that. I'm going to have to find the gear I dropped. It'll take me just a moment. Not the gear, the shaft that fell. It's under my chair. So I can put that one back on. So bear with me for a few moments while I get a flashlight and look under my bench for that shaft. Be right back. Alright, I found the shaft I dropped. So that's what it looks like spinning. I gotta fix this because I pulled the wires out by accident, so I gotta resolder them to the pads. When I was moving this, I still had it plugged into the motor and it yanked the old wires out. So gotta resolder that. That's not a big deal. Solder it and then hot glue it in. But I wanted you to see it's now working like it's supposed to. That loud clicking sound that was earlier, it's much quieter now, is the pulley is warped and the pulley was smacking the bottom and rubbing, so it's going really fast. Also, if you don't screw this piece down, this plate will start to vibrate and lift. So it's a combination of two things. You need to have the center screwed in for compression, and the pulley is warped. I took the pulley and, well, it's plastic, but I tried bending it to get as much of the warp out as possible. It's no longer smacking the plastic housing. So now I need to spend some time soldering this back on. It's not too difficult. You just got to check the polarity, and then I just got to solder onto those two pads there. And on this pad right here, where this hole is the negative, and the one on the inside is the positive. And then this will be good. So, but that was because I forgot the motor was plugged in when I slid this back to bring this over, and it yanked. It broke one of the wires. I desoldered the other one real quick so I could clean them up and fix it. So, but that will now go in there, and then it'll run off of its on-off power. So I'm going to take care of that real quick. You've already seen me solder, so it's just a waste of time watching me solder again. And I wanted you to see, I went and got the packaging real quick since I had to get up and get a flashlight so you can see these guys spinning around like they're supposed to. Be back in a moment with this fully assembled. Alright, it's back together, and looky looky. And then here it is in the dark. Which the LEDs are just drowning it out. So can kind of see it glowing. It looks a lot better in person. Alright, lights coming back. 1 and 2. So, put it all back together. Re-glued it all, like I said I was going to. And as you can see, lights work. Motion's perfect. What I did do, that is, I did remove the Velcro. I had to remove that Velcro because this kept shifting and rubbing really bad. I guess it's a little bit tighter here than it is over there, but it's not rubbing. But with the Velcro, the whole thing kept moving. So I glued it, as you see. And like I said, what I like about this glue is it dries almost clear, as you can see there too. It's almost completely clear. It's picking up a lot of the color from the resin. The Sure Bond that I mentioned in a previous video. So I did use a lot of glue, I ain't gonna lie. I re-glued all the wires, and then the whole ring, it took a stick and a half. So it did take a lot of glue. It's fine. But it now works. All 3 green lights. We got the motion, the counter motion on the centers, so they all spin. So we're good. So that takes care of this. This one can be sent back to its owner. So as far as it goes, it had a bad solder joint on the Molex connector. It had and a bad motor. So this guy is bad. It's all crusty. You can see on this one I was mentioning about clocking it. This one only has 2 screws that line up, not 6. So depends on which one you buy, how many screws it's going to have. So they're screw holes. So other than that, easy. Take the bottom off, pop it out, flip it over, unplug the motor. Sorry. So you can set the top off to the side. You got all the screws. You got 3 on the bottom, 3 on the top for the motor. Not the motor, the gears. You got 3 that hold the motor assembly in with the gears. Flip it over, you got 2 screws for the motor if you have to replace it. Cut and solder. The belt's accessible at that point. Technically, you can probably even do it just by taking the 3 screws out of the bottom and just removing the sign, and you can do everything without separating this piece. But if you have to replace the motor, you're going to have to separate this piece because you have to solder the wires back to the connector. Or if you want to trim them right there and make a loop inside them will not get caught in any of the rotating mechanisms, you can do that too. Worst case is you got to disassemble the whole thing. So, thanks for watching. Till the next one, have a good one.